Welcome to the Databricks Skill Builder series. We're glad you're here.
All right, well, thanks everybody for joining. My name is Pablo. I'm a solutions architect here at Databricks. I think the slide deck will go out afterwards to all the people who have joined in an email. So my email address is right here in the front page as well. So if you have any questions after the webinar, you can definitely email me and I will get back to you as soon as I can. All right, so what I'm going to go through today is some of the UDF options in Databricks, or user-defined functions. Basically, it's going to be a pretty straightforward topic. I'm going to enumerate some of your options, and we're going to go through some very simple examples of what those look like in practice. Whoops. So this is my agenda today. Talk briefly about what these things are, what kind of types of UDFs are supported inside of Databricks, or what type of functions you can use. There are some pros and cons that we can go through in terms of performance and things like that. We'll talk about it at the end. And then we'll actually walk through a real use case where I took a UDF from an outside source, which is a Java jar file, and we'll go through in a notebook and we'll talk about actually all these, and then I'll show you this other use case. And like Stephanie said, if you just came in and if you want to ask a question, you can raise your hand to ask it live, or you can use the Q&A box and we'll get to them as soon as we can. All right. Okay, so UDFs, user-defined function. It actually means different things to different people. It's kind of a loaded term. At the very core of it, it's just a function. It's just a way to modularize your code, make it reusable, make it available to other people, make it centrally managed so that people aren't reinventing the wheel, redoing things that you've already done. And with Databricks, you can use several different types. And you can actually also take some of these and register them so that they are available to not just you, but different people in your organization. And we'll go through that briefly as well. So what I'm going to do is basically go through the different types of UDFs that you can use. And by the way, as we go through, you'll see that I put in a link to the documentation in this deck. After it goes out, after the webinar, if you're interested in some of these topics in more depth, you can come in here and go to the documentation, or you can just go straight to our documentation. So I'm going to go through the list of the different types, and then we're going to walk through most of these in a little sample notebook that I created for this webinar. And basically, there's things like regular functions, not officially UDFs, but they're kind of do the same thing. UDFs you can do in SQL, ones that you can do in different languages that we support. There's UDFs that you can do in Pandas. There's a different type of UDFs, which are aggregation UDFs, which we'll get into. And then this external UDF thing that I have at the last as the last thing is how you can bring external code from somewhere else, whether it's in a jar file or some other supported format, how you can bring it in and kind of wrap that and use that in your Databricks day to day. Okay. Any questions so far, Stephanie? I don't think so, right? No. Okay. All right, cool. So let's get into some of these. For this thing. Okay. So SQL functions, again, here's the docs that are included in this page. There's a couple different types of SQL functions that you can do. There's a scalar function, which just takes in whatever input you give it to, you put into it, and as an output, it gives you a scalar. So it's just one value, whether it's a number, whether it's a string, whatever it is. That is a scalar function. Table function is a SQL UDF that returns basically a table. It returns rows, columns, and you can define obviously what comes out of it. There's a couple different things that you can kind of opt in or out of when you're defining these things inside of Databricks. You can make them temporary, which means they're just available to you in that particular session that you're working in right now. You can make them persistent, which basically, and we'll talk about this in more detail as we go through the examples, which basically attaches them to some sort of a meta store and makes it available for you in other sessions, makes it available to other people, etc. You can also define it with default arguments. You can put your comments inside of there, as well as these things are all securables inside of the platform. So you can give access or you can revoke access to different people across your org if you want to make your code available to them. Okay. All right. So moving on, very similar concept here with language UDFs. So you can do these with Python. You can define these with Scala as well. You can actually even do them in Java. And these have similar options as far as what kind of output you can get out of them. So same thing here, you have a scalar function that you can define, just returns one value. You can define aggregation functions, which are basically going to be like aggregators that can process multiple rows you send into it. Kind of like how you would use a group by statement in an SQL statement. You can define your own aggregation to do, to put into your group by statements, basically. Nice thing about these things is as well that they're portable across different places in Databricks. So you can use them in your SQL queries. You can use them in your Python code with data frames. So they're not bound by whatever language you make them in. You can use them in the different environments as well, very easily. Okay. All right, so next thing here is Pandas UDF. So this isn't necessarily a Databricks specific thing, but it is UDFs that you can build specifically for Pandas operations. So these are meaning that they're vectorized, which is the whole Panda philosophy of processing rows in parallel as opposed to iteratively. These also have some options in terms of what kind of output or what kind of input they can accept and what kind of output they put out. So things like the scalar output, that's obvious, but you can also have them output or taking a series, which means basically a row of things in Pandas, and either output a series or an iterator to go over them. We're not going to go over this today in the examples, but if, like I said, if you are interested in more detail on this, you can get in touch with me later, or you can click on the docs thing here. Okay, so aggregation UDFs, these are a little bit more complex to create. These are, like I mentioned earlier, these are things that will act over multiple rows of your queries. How you would use, let's say, like the sum aggregator or the count aggregator in an SQL query when you do a group by. You can define your own functions to use in one of those aggregated statements. The thing about these is that they are coded in Scala or Java. That you can use them in SQL, you can use them in Python. And the way that they work is you actually have to do a little bit of coding to extend this aggregator base class, which is a Java class, and basically override some of these methods that the function will call when the query is running in order to add values into your aggregator. So there are functions for putting in a whole bunch of rows into your aggregator that you can then write your own custom logic to aggregate over. There's a function that will get called if we're adding a single value. And then there's this function finish, which will basically get called when Databricks is asking for the final result of the aggregation, when there's no more rows or no more values that are going to get fed into the function to get computed. So there's a little bit more coding here that needs to be done, but it's not that complicated. And then you can deploy it in Databricks, and then you can use it. You can share it with other people, and it'll just be available for you from then on. Since it does require coding, there's a couple of different places or ways that you can approach it. If you want to do it in Scala, you can code it directly inside of a notebook. You can define it in a notebook, and then you can use it from there. Or if you want to do it in Java, which is my preference, you can do it in an IDE somewhere outside and upload it as a jar file. And this is actually something that we'll talk a little bit about later on how to do this upload. So then you can use it there. Okay. Yeah, I see a question. Unity catalog overview recording, and yes, Priyan, we will reach back out to you, or Stephanie will get in touch with you about that to put you on the list for the distribution. All right, cool. All right. All right, I think this is the last type that I'm kind of enumerating here. So here's the documentation for this as well. This is how to bring up a library and install it into your Databricks cluster so that you can use whatever code that you created or whatever third-party code that you're interested in using. You can either upload it from your local machine, you can point it to PyPy repository or things like that. What I'm going to walk through in our example here is how I created a jar file to kind of wrap an external function that I'm interested in using, how to call it, and how to pass data from it from SQL. But really, this kind of extends more generically into how you can bring outside libraries into your clusters and how you can start using them in your code in Databricks. So this applies to that as well. And we'll go through this in the demo as well. Okay. Okay, I'm actually going to stop here and I'm going to go into a little notebook that I have ready to go. Let me stop here and see if there's any questions. Okay. No questions, so I'm just going to keep going. So I have here a sample notebook that just shows things that are very simple. One of the things that I want to start with the simplest and just keep going to the things that are more complicated. So I'll start here with just the functions. So even though we're talking about UDFs, and UDFs have a very specific meaning in a lot of different data platforms that are out there, you can always also just define functions, whether they're Python functions, R functions, Scala functions, whatever they are. You can just define those and use those. You don't have to, go to the UDF route. And I think this is probably the easiest thing. So I have a notebook that I've created that it's just called functions. It has this say hello function in here. And when I run this, it just basically reaches out to this other notebook called functions. It runs this where all my functions are defined, and then I can use them in my code. So when I run this say hello cell, it just spits out this hello. Now I can use that everywhere, and I can have like a library of functions that are defined inside a notebook, and they're all ready to go. I think this is probably the easiest thing. It probably applies to most use cases out there. But of course, we'll move on and talk about stuff that's a little bit more complicated and different use cases. Okay. So moving on here, there's a couple of different cells that I've created for SQL functions. And this is nicely documented in our docs as well. So it's very easy to follow along with how these work. This is a definition of a scalar function. You'll notice this, this keyword here of temporary, which means that once I define this function, it is available for me, but it's only available for me, and it's only available in this session. This will disappear once this cluster goes away or terminates. So that's just something to keep in mind as you're defining these. And if I run this cell here, I can see it works as expected. It's just returning the square of whatever input I give it, and it's giving me the cell that's the square of 2. Okay. My next example here is something that's very similar, but what I've done here is I've made it a persistent function. So I've gotten rid of the temporary cell. I'm actually giving it a path for this thing to be defined. So I'm using Unity Catalog here, but this also works with the Hive Metastore of the days of yore. So I'm giving it a catalog, I'm giving it a database, and then I'm giving it the name of the function. So this function will now get attached to this path in Unity Catalog, and will now be a permanent fixture inside of my Databricks instance for me to use or for me to share with, with whatever other users are interested in using my stuff. Yeah, and as I run this, it just basically defines this, and now I have that available to use whenever I want in any of my SQL queries, any of my dashboards, et cetera, et cetera. Okay. Okay. And just a couple more examples here. So this next thing is also a temporary function, but it just has a couple different options. Things like comments, things like default values for my inputs. So the syntax of how these things are defined is a little richer than when I showed you, than what I've showed you up to now. Just know that there's a couple different options that you can do, and a couple of different ways that you can define it to make it easier for you to look at.
Hey, Paula, we've got a question.
Yeah.
The question is, would the temporary function be part of the Spark session or the cluster?
Yeah, so it's actually part of the session. Yeah, cool. All right, yeah, thanks for that. All right, and then the last SQL function here that I have going is an example of a table function. So, so this is another temporary function, but what this does is it actually will return not just one value, it'll return a table of values. So what I have is, as inputs, I take an X and Y, both integers. It's going to return a table of 3 integers, basically. And I'm basically just using the functions that I've defined up to now to just create just a bunch of data. So I'm going to create a sequence from X to Y. I'm using this explode function that's built into Databricks that basically explodes an array into rows. So I'm making rows, and then I'm just outputting the number, the square of the number, and the cube of the number. And that's all it is. So once I define that, and I do a select all from my power sequence. So this power sequence takes in the 1 to 4, basically explodes it into rows that are 1 through 4, and then it does the square and the cube of each one. So let's see. So basically this gives you this table. Yeah, let me see if there's any questions here. No questions. Okay. All right, so this is a way for you to basically take any input, take whatever processing you need to do, and output it as any other plain old table that you would see in any typical SQL select statement. Okay. All right, moving on to UDFs that you define in languages. So I have one example in Python. It's basically, an extension of a regular Python function, right? So you define a Python function. This one again is doing just squaring. And then you tell Spark, hey, I'm going to register this thing as a UDF. I'm going to call it this. And this is my function object that you should use, or that you should call into when someone uses this UDF. And once this is done, now it is registered, ready for me to use. And like I mentioned earlier in the slide deck, You can use this in SQL, you can use this in Python, you can use this in other languages. So really when I run this cell, show that result. Whoop. Let me define it first. All right. So same result again. Square of 2 is 4. And that's it. So even though I've registered and made this in Python, I can run this in SQL and use it in any of my queries, dashboards, etc. Okay. I see, is the UDF stored in the session as well? Yes, it is. I believe it is just for the session. All right, cool. All right, let me stop here and see if there's any other questions before I get into. Yeah, so I think I need to double check this, but I believe it's stored in the session.
Yeah, I would agree.
Yep. Yeah, and Mimi, that is what I'm going to get into next. Thank you. All right. Okay, so actually, yeah, one of the things that actually, before I move into the Java stuff, one of the things that where you can put a UDF into as well is one of our machine learning models. So if you have a model defined in MLflow, or if you have a model defined somewhere in your workspace, and you want to plug it in and make it into a UDF so that you can use it inside your select queries, or you can use it inside of any pipelines or any things like that, inside of all your data flows. You can plug any of your models right in by defining them as UDFs. So that is something that'll give you a whole bunch of flexibility in terms of how you can use your models inside of pretty much anywhere inside of Databricks. So yeah, thanks Mimi for bringing that up. Okay.
So it looks like we have a couple questions around being able to permanently register it and whatnot. You want to grab those, answer those?
Yeah. Okay, so those are kind of related. I actually don't know the answer off the top of my head, so let me look into that. If you wouldn't mind putting your emails, if anybody's interested in knowing how to register these UDFs permanently to the workspace, if you want to send me your emails over the chat, I will take a look afterwards and I will get back to you. All right, cool. Stephanie, can you take down these emails?
Yeah.
And this last question here, how to create a UDF in Python. I believe that's the last thing that we just talked about, is basically registering a Python regular function as a UDF with Spark. All right, cool. All right, perfect. All right, so I think we're good on the answers right now. Yep, so I'll just move on. All right, so this will be the last kind of example that I have here. So this is a real world example of something I did a little while ago, basically bringing in an external jar file and using it inside of Databricks. This is actually a jar file that came from another vendor called DataRobot, which is a vendor that we also partner with. And the customer wanted an example of how they can take a machine learning model that was created in this third party, and how can they use it to do mass scoring of the model across multiple nodes in our clusters, et cetera, et cetera. So the way that works with these DataRobot models is that you can export them as a jar file. So, what I worked on was taking that jar file, putting it inside of Databricks, and then making the glue code to be able to use it directly from Databricks SQL, or from Python, or from whatever it is. So let me start a little bit off with that. Show some of the code that we use here. So this jar that was given to me, this test jar that was given to me, basically allows you to bring it into a Java program. This is the method that is made available to it, to your code, to basically call into this jar file, run this model on whatever data you put into it, and then take the output out. So I took this jar file, I did a little bit of a wrapper here. So this is the method that I created. It takes in a map of a string and object types as input, and it returns an integer, basically a 0 or a 1. This is a classification model. So it returns a 0 or a 1 based on yay or nay, or whatever this model is predicting. So once I got this jar, once I made this very simple kind of wrapper around it, it's time then to compile this into a jar and upload it into DataRobot. So I'm sorry, Databricks. Let me move this thing out of the way. So if I look at my cluster, this is the cluster that I have created for this webinar, or that I usually use. If you look in the Libraries tab, you'll see a couple of different things. So this one you can ignore. This is for something else that I was working on. So this is the model that was outputted from the third-party vendor that contains this model that I want to start using in Databricks. This is the jar file of my simple simple kind of wrapper that I just showed you. So now anything that I've made available in either one of these things, either one of these jar files, is now available for me to use and for me to call into from any code that I have running in my cluster. So what I'm going to do at this point then is start referencing that jar file. And you'll notice here that this is built in Scala. This is my life's work and achievement when it comes to Scala coding. This is the only Scala code I've ever done. And the reason why it's done in Scala is because some of you may know Scala and Java, they run in the same runtime. So they can also share data. They can share objects. So they're basically, when it comes down, when the rubber hits the road instead of the runtime, they are the same thing. So this is the reason why I'm defining it here, and why this is the required glue to make this happen, from being able to call into this jar file. So right here I have my import my stuff, org.pablo. Everything else that's in there. This is my package. This is the function that I define inside of my code. So if you remember that, this is the function that I've created here. So it's calling directly into this function. It is sending in a map of stuff, which we'll get into in a second. So this is just a dictionary. It's called map in Java and Scala, but it's the same thing. It's basically a list of key value pairs, string and something else. And it returns an integer. And basically what it does, it just calls in the org.pablo.udf package. There is that function called udf_dr, and it sends in my stuff, or the input. And then what I do is I register this as this. So this will be the name of my UDF inside of Databricks that will, call all the stuff that I was just talking about. So when I run this, this stuff will get registered. And then it'll be available to use for me to use anywhere in Databricks, in SQL calls, in Python calls, et cetera, et cetera. So I have a very small data set that consists of 2 rows that I'm going to run this on. So I have this UDF data set that I'm going to apply this UDF to basically do, hey, here's my input data, here's the actual label, and I'm going to run it across my UDF to make predictions. The good thing about this is that if you want to do scoring at scale, whether it's a third-party model like this, or whether it's a model that was created inside of Databricks, whether it's through AutoML, whether it's manually in a notebook, whatever it is, when you define it as a UDF like this, it will automatically handle, deploying your code out to 1, 2, 3 dozens of nodes, however big your cluster is. And it'll automatically handle, running all the data and all the predictions through it, and maybe writing it to a Delta table or outputting it for you, or or passing it on to some other part of your pipeline. So this is a great way for you to do scoring with your models at scale very easily and very quickly. Okay, so then this is the data that I'm going to model, or that I'm going to score, and I'm going to use this in a select statement. So here I'm going to select all from that data set table. And what I'm going to do to pass this is, here's my UDF, and the synonym or the synonymous thing here in SQL with a Java map or a Scala map or a Python dictionary is this map function. So I'm going to send in all my data as a map, and the glue code that I created will automatically convert it so that it'll eventually be a Java map that gets sent into my code. So I'm sending in the variance, the skewness, all the different variables inside of my data set. And this will come back, and I'm going to call it prediction. And I also want to select the class so that I can look at them side by side. So when I run this, I've actually already run this, but you will see that all the data goes through. The prediction is here, the actual is here, and all this code has been glued together in order to do this very quickly and to do this at scale if you needed to. Okay, I'm going to pause there. So see if there's any questions here. All right, and I don't see any.
No, there's only one question that I'd already answered that asked if the notebooks could be sent out, and I just said we could send them out with the recording.
Okay, yeah, definitely. All right, cool. So then we're done with this, done with the notebook. So let's just wrap it up. We'll wrap it up with the next, with a couple slides here. So there are some things to think about when you're using UDFs. The documentation page that I have linked here is really, really good in explaining some of these considerations. So make sure to check that out. But there's really some guidance on what is most performant, and what are, depending on that, it's probably a good idea for you to look to see what it is that you're trying to do with the UDF. Does it make sense to do that? Or is there a better option? So as you all probably know, Spark has an optimization engine built inside of it that basically looks at all the stuff that you're trying to do in any particular call, and automatically rearranges and massages stuff to make it the most efficient possible. When you define certain types of UDFs, those things are like a black box to the Spark optimizer, so it won't be able to optimize them. So it may or may not have some sort of bottleneck or some performance issue. So that's something to think about. And in this docs page, if you look at the bottom right of this slide, that's basically lifted completely from that docs page, which will give you some guidance on which type of UDFs are we able to automatically optimize for you, which types we are not, and what are some of the different considerations for each one. Okay. All right, I guess that's it. You already did the demo. All right, so that's it for that. Let me go into the questions here. This question call that says, what is glue code? Really, that doesn't really mean anything. That's just something that I was referring to when it comes to being able to bridge the gap between using a UDF inside of my SQL code and being able to call into a Java function as part of that. I just refer to that as glue code. It's not really an official thing. It's just kind of integration code, I guess you can think of it that way.
Any other questions? Don't be shy. All right, well, with that, then I'd like to thank you, Pablo, for your time today, and thanks everybody for joining.